In this video, I will try to explain it in an easy to understand way, the various components of AWS VPC and how they work together through this diagram. The diagram shows a setup for hosting a website or application on Amazon Web Services or AWS. Think of it like this. AWS provides the space, the power, and the tools for your website to live. The VPC is like a private area you set up within the AWS space. It is a secure place for all your website stuff. On the far left, you see people using their computers to access the website. The first thing they hit is CloudFront, which is like a super fast delivery service for your website. It brings the website closer to users, making it load faster. Next is the Internet Gateway, which is how your VPC connects to the outside world. The application load balancer is a traffic controller directing the users to the right place. The website itself lives inside what is called web instances. Think of them like powerful computers running. Instead, the load balancer acts as a gatekeeper, only allowing valid traffic to reach the web servers. This way, potential hackers or bad actors cannot directly access the internal parts of the system. Does that make sense so far? Now, let's talk about the difference between a public subnet and a private subnet and when to use each one. Think of a subnet as a section within your VPC. A public subnet is like a room in your house that has a window directly facing the street. Anything in this room can be seen from the outside and is also able to make requests to the internet directly. In the context of the diagram, things like the application load balancer that need to be accessible from the internet are usually in the public subnet. On the other hand, a private subnet is like a room that doesn't have a window facing the street. It's more secluded. Things in this room can't be directly accessed from the internet. Instead, they can request things from the internet through a net gateway. In the diagram, things like web instances and databases are usually in private subnets, which helps protect them. So, when do you use what? You typically put things that need to be directly accessible to the outside world, like load balancers or certain web servers in a public subnet. You put most of your other resources that don't need to be directly accessed from the internet, like databases or applications, in private subnets. This setup is really important for security because it keeps the most important parts of your system hidden from the open internet. Think of the public subnet like a security checkpoint, while the private subnet is where you keep your valuables safely inside. Now, let's talk about the difference between an internet gateway and a NAT gateway, and when to use each. The internet gateway is like the main door to your house. It's what allows your entire VPC to connect to the internet, allowing people from the outside to come in and assess what is in your public subnet. It's essential for any resource in your VPC that needs to be directly accessed from the public internet, like a website. The net gateway is more like a special one-way door. It allows resources in a private subnet, which aren't accessible directly from the outside, to make requests to the internet, but doesn't allow the internet to initiate connections back to them. Think of it as a tool for resources that need to update software or send data out to the internet without being exposed to the outside world. So you use an internet gateway when you want resources in a public subnet to be available to the public internet. And you use a NAT gateway when you need resources in a private subnet to communicate with the internet. It's like downloading updates, but you don't want them directly accessible from the internet. Now, let me tell you why we need an application load balancer and how it helps with creating a highly available and fault-tolerant design. Imagine you have several web servers that can handle requests, but you don't want users to have to pick which server to connect to. That is exactly the job of an application load balancer. It sits in front of the servers and acts like a smart traffic cop, distributing incoming traffic evenly across all of the healthy servers. This ensures that no single server gets overloaded and users get quick responses to their website requests. Now, how does this help with high availability and fault tolerance? The load balancer continuously monitors the health of the web servers. If one of the web servers fails, the load balancer will stop sending traffic to it and only direct the traffic to the healthy servers. In the diagram, there are 2 availability zones with web instances in each. If all the web servers in one zone fail, then the load balancer will make sure all traffic goes to the healthy web servers in the other availability zone. This means that the website can remain up and running even if some of the web servers fail, thus making your system more fault tolerant. Also, distributing the traffic across multiple servers ensures that your system can handle more users and traffic without slowing down or crashing, which is essential for high availability.